Okay, everyone, thank you for coming. So this week we'll talk about singleton pattern. So I do have a good collection of questions there from your Word documents, but if you do plan to do your quiz between today, maybe just right after today, you cannot wait until tomorrow. Let me repeat the tips that I mentioned to you guys on the forum, on the announcement. I think for this week, you want to pay attention to the small details about how you can understand each components of the singleton pattern solution. Okay, let me give you a little bit of hints over here. Okay, I cannot say too much, but I can definitely give you the direction you want to focus on. For example, you can see this is the singleton pattern that we talk about ultimately in the slides. So you may want to focus on every individual components for the singleton pattern. Think about these guys over here, and also this guy over here, and also this guy over here. So these are the important pieces you want to pay attention to, okay? Not only that, well, of course, you don't want to memorize that. You want to understand why we actually put it over there rather than not putting it. So that would be my tips for you to get prepared for the quiz this week. And also, of course, you want to make sure you understand what expanded class really means. We do have some good questions from your fellow student, which I'll talk about. And also understand the once routine as well. All right? Okay, let's start from the beginning for the questions. The first question there from your fellow student is very brief. They were simply just asking about what the difference is between expanded class versus deep twin. You might be wondering something about it too. I would say they do share some similarity there, but I don't want you to get confused. So that's why I kind of created some small example to show it to you. Okay, I'll make the source code available to you once I post the recording tonight. Okay, but for now, let me just go over with you the classes and also the test cases I have set up. I try to make them somehow similar to what you have seen in your lecture, but I do extend it a little bit so you can see the difference. Okay. Anytime you kind of get lost in the code, please just speak up, and then I will go slowly. Okay. But now let me go over the classes together with you. Okay. So now I want you to notice that we got two expanded classes. Okay, two. So we got expanded class over here. We also got expanded class over here. One is called B1. The other one is called B2. Okay. What's the difference over here? Okay. So now notice that. So now not only that we got I integer and also I integer. I'm now introducing a reference type attribute. So that's a new addition. That's from your lecture. Okay. Just since you guys asked me the difference between deep twin and also the expanded class. So I need a reference attribute to show you. So now notice that we got string and also string. So attributes are the same between the two classes, okay? And they're both expanded. I mean, the classes are expanded. And then we also got a foreseeable, change I and also change S, change I, and change S. So these are very simple, okay? And then notice one thing here. Let's say this. In order for me to actually say, if I declare EB1 over here, and also EB2 over here. So one thing I emphasized back in your lecture is by saying, if these two variables are simply just expanded type, that means you don't have to explicitly initialize them, right? That's what we said. Okay. So there's something I didn't really say, just not to confuse you, but since you asked, so I can give you more complete information. Okay. So now, before this, you can think about implicitly, EB1 and EB2. They will be initialized as follows. Okay, let me write it down exactly. This is always the case. So you can think about implicitly, which means you don't have to do it explicitly. Implicitly, let's say just for EB1, you will actually get creates EB1 dot default creates. Okay, it's spelled exactly like this, default creates. Meaning that the reason that you don't really have to explicitly initialize an expanded variable is simply because implicitly they always call the default creates. And the default creates is when you only have, let's say, when you only have the primitive attributes, in that case, they will just initialize to their default value. However, when you actually got, let's say, reference attributes, in that case, you have to be explicit about what their values should be, because the default value for reference attribute will just be void, which is not allowed, right? We'll run into the void safety issue. Let me draw a little bit of analogy to you very quickly, right? think about back in your Java course, right? When you got, for example, a class, let me say A over here. Okay, just go back to Java just quickly, temporarily. Okay, so now if I have this, and then let me just declare some attribute over here. For example, I might have integer I, and maybe string S. Okay, in Java. Okay, so that's the supplier's code. And now in the client side, can I say A, object A, is assigned to new A over here. So would this compile? Just a very quick check for you. Would you agree that compiles? Yes, very good. Okay. The reason that it compiles because when you actually do not actually explicitly declare any constructor in your class, this is something that's default constructor. Default constructor, which takes no input over here. It's kind of similar to the default creates we have over here. So that's one connection I want to make. And number two, when you say default constructor over here, it will be as if. You say A over here, and then it will simply just do nothing. That's what a default constructor will do. Meaning that it's as if we said that string S will just be assigned to just null, right? So S will just be assigned to null. However, in the Java context, this will be okay because we don't really check for void safety. But in the context of IFO, you cannot simply just let your default constructor do nothing, because if you simply leave the reference variables unassigned to the something that's attached, you will run into void safety error. That is why, now let's go back to IFO, right? I just want to draw some connection for you. If, given that we know, whenever you're trying to declare some variable of expanded type over here, like an EB1 and EB2, implicitly, the default creates will be called. Right? But now, since each of the expanded class, they actually got a string value over here, which is reference type. Okay, so this is a reference type. So this tells you that implies you must initialize it in the default constructor. Otherwise, you will get a void safety issue. Okay, everybody's okay so far? Okay, I hope. Okay, I'm watching the chat just in case you want to have any question. Okay, let's go a little bit further. So in Java, if you want to overwrite the definition for the default constructor, the way you do it is by simply just declare this constructor without any parameters. And then you might simply say over here, S maybe is assigned to, for example, Alan. That's what you would do. In IFO, you would just need just one extra step. You have to say you want to redefine the default creates. And the way you do it is by saying you inherit from the any class, and then you're trying to redefine the default creates. That's what you got to do. And now when you see the default create over here, we simply say create an empty string over here. So that's what we're saying. Okay, and we do something very similar to B2. So we say any, and then we say redefine default creates. And then we also try to redefine the default create over here to say create as the make empty. Okay, guys, so far, any confusion, please, you want to speak up, because we have actually we got three relevant examples in total. So I want to make sure you're okay with the setup so far. Any questions? Okay, seems like everybody is good. Okay, interrupt me anytime. Let me say one more thing. So now, so far I talked about what's in common between B1 and B2. They're both expanded. The only thing they are different is as follows. I want you to pay attention to this guy here. You can see inherits from any, redefine is equal. So that's where things get a little bit trickier. Okay, I'll show you. So now for expanded class B2, what I will do is I'm going to say is equal over here, and then I'm going to say we should really compare I and also S, right? The way you compare the I is by simply using an equal sign. It's because its primitive value doesn't matter if you use equal or tilde, doesn't matter. However, notice over here, we are saying that if you want to use the tilde over here, this one here means you're going to compare by contents. Okay, that's something very important for you to notice. Okay, let me just say one more thing. So now we know that for B2, if there was a scenario where you want to use tilde for B2, you will actually have to call this redefined version for the ESequal, where the string will be compared using tilde, number one. Number two, what happened to class B1 over here? Class B1 was not redefined for its ESequal, so which means it's going to use whatever default version it is from, inherited from the any class, right? So now let me write it down quickly, okay? So now for B1 over here, is going to have the default version of ESequal. And then whenever you talk about default version of ESequal here, I haven't really spoken about this so far because the way they do the default ESequal query is somehow different from Java. So that's why I didn't really talk about it to confuse you. But let me just give you the precise detail right now. So I can tell you that once you walk out from this particular example, the lesson will be anytime you believe if your classes are going to be compared by contents, always redefine the ESequal just to avoid some inconsistent behavior for the default version of the ESequal if you're always confused between a Java and iPhone, okay? So now, what will be the default version over here? The default version will be, we still got the same signature over here, but now what that will do is, let me write in a different color here. So what that would do is, it's going to compare attribute by attribute using just the equal sign, which means it's going to do I equals other.I. Okay, that one's easy. That one's actually pretty easy, straightforward. And since we got two attributes, what about S over here, right? Even for reference attributes, they will also use equal, which means that they're going to compare by reference. Okay, so if you think about back in your lecture example, when I say when you compare the expanded objects, you always compare by contents. It's because I use a simple example where you only got primitive attributes. But now I'm just giving you a little bit more general scenario. So you want to, what you want to think about is whenever you say, for example, EB1 equals EB2, if they're of type B1, so this equal here is actually going to call the default version of the ESequal. And that one there is actually going to compare everything using just the equal sign, okay? And then that one there is going to be S equals other dot S, okay? So far, I'm just trying to explain to you what's really happening over here, both explicitly and implicitly, before we see the code. I will pause here a little bit. Do you have any confusion or questions, please, before I move on to trace the code together with you? Any questions? Everybody is okay? All right. Okay, so now let's take a look at the source code over here. Okay, I'll make it a little bit larger for you to read. Okay, let's do one by one. So right now, let me just wipe this out. Okay, over here. Okay, good. So we got EB1, EB2. So let me say over here. We got EB1, EB2. They are of type B1. And also we got EB3, EB4 of type B2, right? Just make sure you have that distinction. And now we want to know that whenever you say EB1 equals EB2 versus when you actually, oh, let me be consistent here. Bear with me. Whenever you say EB1 equals EB2, and also whenever you say EB3 equals EB4, EB3 equals EB4, right? For the first one here, it is as if you said EB1 tilde EB2. And similarly, when you say this, it's as if you said EB3 tilde EB4. And based on what we learned before, whenever you use tilde, it's going to call the ESequal query from the class, right? So now you can see that the ESequal for EB1 and EB2, since they're of type B1, so you're going to call this particular version where the string attribute is going to be compared by reference. On the other hand, when you do EB3 tilde EB4, that one there is going to call this redefined version of the ESequal, where the string value has been redefined to actually call on the tilde of the string, which means it's going to compare the contents of the string. Okay, that's a very quick. If you got this so far, I think everything else will be straightforward. Let's go try it. Okay, so now what we will see is you can see we don't need to explicitly initialize EB1, EB2, EB3, EB4. They have been initialized already, right? So what we will get is how will EB1 be created? So EB1 over here, okay, let me put it here. So EB1 is of type B1. And also EB2 is of type B1 as well, right? So now, in order to initialize EB1, we have to look at its default creates over here, which will simply create S to be an empty string, and then I will just be the default value. Okay, so now we got I, and also S, and also we got I, and so we got S. So I will just be 0, and also S will be an empty string, and S will also be an empty string. Notice that even though they're both empty strings, but they're different strings, different objects, right? They're like a different pointers. Okay, so now if you look at the assertion we are trying to make, so EB1.I should be equal to 0. EB2.I should be equal to 0. That's good. And also EB1.S not equal to EB2.S. That makes sense because this string here is not the same string, right? They are not by addresses, by reference. So that's not equal. However, when you do EB1.S tilde, are they different string but of the same contents? Yes, they are, because you can see over here, empty string, tilde, empty string will be true. So you can see this whole conjunction over here will just be true. The whole test is going to pass. So that's why I put the assertion this way. Okay, so now let me go on a little bit, and then I'll see if you got any questions. The next one, when I try to say over here, when I say EB1 not equal to EB2, okay, this one will be something that you have to watch out for. Okay, let me say this. When I say EB1, oh, actually, you know what? I said it already. Sorry, I forgot. So you can see EB1 equals EB2. We know that it's going to call EB1 tilde EB2, and then which will boil down into calling this default version of the is equal, right? So what that will do is I equals other.I, other.I, they are equal. And then S equals other.S, is this string equal to this string over here by reference? No, they are not. So that is why this one over here, if you simply say EB1 equals EB2, it's going to give you false. That is why I simply put not equal to over here. So the result will remain to be true. That is why. Okay. Guys, I hope I haven't lost many of you. Okay, do you have any questions? I'll read out one question here from Tempeh. Every time we redefine is equal, we redefine the symbol equals, not tilde, right? Same thing for not, okay. So I think I kind of know what you mean. Let me just emphasize here. The default version for is equal is going to be, we compare every attribute just by the equal sign, okay? In the case where the both sides are simply just primitive value, you're just comparing their contents for primitive value. On the other hand, if the both sides are simply reference type, in that case, equal sign will mean you compare their references. So if you really want to override that behavior, you will need to say redefine the is equal. In this case, when you say is equal over here, you can see we still want to use equal for primitive type, but now for the reference type, we're going to use tilde. So that's how we redefine, okay? And you do something similar for reference type as well, okay? Just by redefining is equal. So that's why I said the take-home message from this example here, always, if you believe you're going to use tilde on the objects of your particular class, always redefine the is equal, just to avoid any undesirable consequence, okay? Okay, that's about the first one here. Okay, I hope everybody's okay. So let me now talk about EB3 and EB4. Okay, let me use different color here. So EB3 and EB4, you can see they're of type B2. Okay, so now again, B2 is also expanded. You can see their default create is also going to create just empty string. So we are going to initialize EB3, EB4 in a similar manner. Okay, so now let's do that first. EB3 is going to be of type B2. And also EB4 is going to be of type B2, okay? And then we also got I and S, and also we got I and S. Because the default create is simply just the same. So I will just be default value, and then will just be empty string. So now S is pointing to some empty string. You can think about we got 2, we got 4. 1, 2, 3, 4. 4 different empty string objects. Okay, they're simply different by addresses. Okay, so now let's go a little bit further here. Let's first of all do some simple check. You can see that over here, eb3.i equals 0, eb4.i equals 0, and then eb1.s not equal to eb2.s. They're not the same, basically the same as before, and their contents should be the same, right? Okay, this one's fine. This one's fine. But now notice this. From before, you can see when I say eb1 not equal to eb2, that will be the case. But now it will be the opposite. When I say eb3 equals eb4, it will be true. Well, why is that true? It is because when you actually say eb3 equals eb4, you're basically calling eb3 tilde eb4. So now, which version of the is equal are we calling? We're basically calling this redefined version over here. This is equal. That's the version we're calling because we talk about eb3 and eb4 of type b2. Okay. So when you're calling that, you're basically I should be equal, but s should be equal by contents. So now if you see that I should be the same value, it is true, and then these two empty string, if you compare them by tilde, is going to be true. Okay, so now that's why this thing here should be true. Any questions so far?
Professor?
Go ahead, question.
What about EB1 comparing to EB3?
EB1 comparing to EB3. You know what, that's a good question.
And vice versa.
Something like that, right?
Yeah.
It's a very good question. I do not have a definite answer over here. Why don't we find out? Okay. First of all, let me say this. Maybe this will compile, but I would say the following. Let me check this. You're basically comparing some objects, which is of type B1, versus some objects of type B2. You're basically comparing apple with banana. I would think you don't want to do that in the first place anyway, but let's try. Maybe compiler will allow that. Yeah, that's exactly what Nora said, but let's see if iPhone will allow that. Okay, let me just try quickly. So basically, it's basically this test over here. I will just do the following. Why don't I say this? Okay, let's say result is assigned to EB1 equals EB3, right? You can see EB1 of type B1, EB3 of type B2. Now, why don't we try? It actually compiles, okay? And then if I say check over here, you know what? I would suggest the following. Can we just leave this over here? Let me play with this a little bit. I suspect when we say result EB3 equals EB1, this might boil down into EB1 dot is equal EB3. And this one might boil down into EB3 dot is equal, and then you would say EB1. So now I suspect this one here is going to call the version of is equal from EB1, which is the default version. On the other hand, EB3, this guy here, is going to call the, this one is going to call the default version from EB1, from B1. And this one here is going to call the redefined version from B2. That's my hypothesis. But I would say, why don't I keep this in the comments? I will look into this. Maybe I will present this to you maybe tomorrow at first, so I don't need to waste your time. Would that be okay?
Yeah, for sure.
Okay, very, very good. But I think it's a very good thinking there, but I would say even though iPhone compiler allows this, but you may not want to do this in the first place. It's just curiosity, right? You're really comparing two objects of different types, which you shouldn't do anyway, okay? All right, let me just continue with this, okay? So now we're up to here. So now, one more thing. I can play a little bit of trick to make sure I can have EB1 equals EB2. How? Since I know that when I say EB1 equals EB2, it's actually going to compare these two things by reference. But now they are not the same reference. I can make them the same reference. I can do that. I can simply say, for example, over here, I would say EB1 change S to be EB2.S. I'm basically saying, okay, EB1 change S. Change S over here is simply going to reassign the S to be something else. right? So now you can think about the NS over here is really EB2.S. So now I'm really saying that EB1.S, rather than pointing to over here, is now going to point to just the same empty string objects. So now you can think about after this, the consequence is EB1.S equals EB2.S is actually true. So they are really referring to the same objects. So now in this case, if you try to call EB1.EB2 again, you're still calling the same default version over here. So we are still comparing the two strings by equality, I mean the reference equality, but now you'll be okay because they're really pointing to just the same string. So this will make it true this time. Okay, hopefully you can see my point over here. So what my point is, expanded class is really meant to really try to avoid sharing if possible. It's more like an aggregation in your 2030. So that means you want to be very careful when you try to introduce reference attributes in your expanded class. Okay, but I would say the typical use for expanded type in this class, in this course over here, is to implement the singleton pattern. That's the one. However, later on you can maybe consult with me later when you're doing your lab number 3, when you're doing your projects. If you do believe there's a particular part of the modeling for your model that you want to use expanded class, we can discuss that to really avoid any confusion. Okay. Okay. Finally, if I try to do here, if I say EB3.change S and then EB4, so I'm really calling the change S from here. So now I'm basically saying NS over here will be EB4.S, basically EB4.S. So I'm really saying EB3 over here. So EB3.S, rather than pointing to over here, is now going to point to over here, right? So they are really pointing to the same object. So this will still be just true, right? So by calling the redefined version over here, so since they refer to the same object, so tilde is trivially true, right? The same object should really equal to itself, basically. Okay, guys, it's quite a bit of details over here in this example, but do you have any questions you want me to explain? Any questions? Okay, as I promised, not to waste your time today, tomorrow in the beginning, I'll tell you the answer for these two, and then maybe I will summarize what you should know. Okay, I'll get back to you on this maybe tomorrow. Okay. So now let me just move on to the next related example, but now we don't have to compare the two classes anymore. Okay, the follow-up example is like this. Okay, so your fellow student was wondering about what's the difference between expanded class and also deep copying. I would say they are different. They are not necessarily the same. Let's just see two more examples quickly, right? But you got all the basics you should know. So we still got this B1 over here, exactly the same as before. Nothing changed for B1. Okay, let's just go over some code over here. I think this part here is just the same as before about the initialization. Okay, let me just put EB1 and EB2 here. Okay, the same as before. EB1 and also EB2. So we got B1 and we got B1 over here. Okay, so we got I, we got S, we got I, S, 0, some empty string, 0, some empty string. The same setup as before. And then it should be no surprising that EB1 not equal to EB2 will be false. Oh, sorry. So this will be true, actually. This will be true because you can see this string over here is different from this string. That's why when you call the default version, it will be false. Okay, so now let's try the following. Okay, what we want to do is we want to say EB1 over here change S to be Alan. Okay, let's do that first. So EB1 change S to be Alan. So now rather than pointing to empty string, we're now going to point to just Alan. But you can still see that this string here is different from this string, still different. Okay, but now here's a critical thing I want to show you. When you do copy, what happens when you say EB1 is assigned to EB2, right? How do we understand it? So now when you do EB2 is assigned to EB1, what I said in the lecture was you're going to copy the attributes one by one, right? Again, I was being a little bit incomplete in the lecture because we only got the primitive value, so I can stay in a simpler way. But now I need to be more precise. So when you try to do object copying for using assignments over here for expanded type. Similar to the default version for is equal, you'll simply just use the equal sign over here, right? In that case, the default copying will just use assignments, colon equal. So what that would do is as if we say eb2.i is assigned to eb1.i. Also followed by eb2.s is assigned to eb1.s. So now you can see the difference here. Since you're copying, when you're copying the primitive value, you're copying the value. But when you're copying just the reference type, you're copying the address because we're just using assignments symbol over here. Okay, hopefully you can see that. So now when we do that over here, you can think about eb2.i over here is assigned to eb1.i. So change from 0 to 0 conceptually, right? And then when you do eb2.s is assigned to eb1.s. So now eb2.s, rather than pointing to this empty string over here, is going to point to the same Allen objects over here. So now you can see for expanded objects, even though there was no sharing after the initialization, but after this particular line over here, we are really, after this particular line over here, we really have created some sharing. Created some sharing, okay. Okay, so far so good. So now if you try to do some checks, so now let's say eb1.i equals 0, eb2.i equals 0, 0 and 0, okay, that's not a problem. ebi.s equals eb2.s using reference, of course, because they're really pointing to the same. So eb1.s over here, eb2.s, they're just pointing to the same string. So this part here should be true. And since there's the same object, so equal should be the same, right? So that should be true. Finally, what happens if I say eb1 equals eb2? So now, based on what we have learned previously, so now we know that eb1, eb2 of type b1. So we're going to call the default version of the is equal, which is going to compare just using equal. So now when we do that over there, so that I'll just say default version. Okay, since we're going to call the default version over here, so 0 equal to 0, and also this is pointing to just the same object as this, so they are the same. Okay, so that will be true. All right, any question about the second example over here? So if you already got understanding from the previous one, so now the second one should be easier. Okay. Yeah, so Amir actually was asking, he's wondering how come iPhone allows comparing apple with banana. I definitely agree with you. So let me find out some good explanation over here. I'll come back to this maybe tomorrow. Okay, bear with me. Okay. And Tempeh was asking, can we say it's a shallow copy? You mean over here? Yes, you may say it's a shallow copy. Yes, you're just simply just using the assignment over here. Yes. You may think it that way. Yeah. Okay, finally, let me do the third one quickly, okay? Since your fellow student was asking about expanded class, so that's why I just show you how you can do copy with the assignment using, you can copy from expanded object to another using assignments, right? Let's talk about deep copy quickly. So so the main point is they are different. That's my point. Okay, so let's take a look at the final example here. So we got B1 over here, okay? So now let me run a little bit more quickly. So basically almost the same example, okay? So now this part here, we have talked about it. So let me just draw that again. We got EB1, we got EB2. So B1 and also B1, okay? And also we got I, we got S, we got I, S. Initially 0, empty string, 0, and also empty string, right? So now let's try this. This one here, EB1 change S to be Allen, okay? So EB1, so rather than pointing to empty string, it's going to point to the string Allen. That's what we do first. And then what we do is we're going to say EB2 is now assigned to EB1 deep twin, right? So how do we understand this? Okay, you can think about, first of all, you have to really, well, think about this. You have to create a deep twin first, and then do the standard expanded object copy. That's basically what you have to do. Okay. First of all, let's do an EB1.deep twin. Okay. EB1.deep twin over here. Let me use a red. Okay. How do we do EB1.twin? EB1.deep twin. Okay. Of course, you cannot really refer to it directly, but I'm just showing you under the hood what's really happening. EB1.deep twin is going to be a completely new object over here of type B1. And then we're just going to copy attribute by attribute, recursively using deep copy. So 0 will be just 0. S over here will just be a brand new string. If S happens to be a more complicated object structure, you will just be deep copied recursively, right? And then will just be Alan. Okay, so far so good? All right. So now let's try this. And then, so that'll be step number 1. Step number 1. And let's now talk about step number 2. So this will be step number 2. For step number 2, you're basically saying EB2 is being copied to this particular EB1.deep twin, right? Again, we do something similar. You're going to copy from 0 to 0. So 0 to 0, similar. And then you're going to copy from Alan to this particular string. So rather than pointing to over here, it's now going to point to this particular string Alan over here. You pretty much like assigned to, right? You can think about EB2 dot I is assigned to, let me just refer to this object here. It's assigned to EB1.deep twin, okay? And also EB2.s is assigned to EB1.deep twin, this object here, .s, okay? I can see this Alan here is still different from this Alan over here because this Alan comes from the deep twin of EB1, right? So it's still different. Okay, finally, you can see this EB1.i, 0 and 0, 0 and 0, and then their strings are different for sure because they refer to different string objects. However, they are the same content because they're both Alan. Okay. Finally, if you say EB1 not equal to EB2, would that be true? Well, it will be true because EB1 and EB2 of type B1. So you're going to use the default version of the ESequal. So now we're going to compare basically to say 0 versus 0 using equal. That's okay. However, this string over here and this string over here using equal, they are not the same, right? That's why you had to use not equal in order to get true. All right, so that's about the second example over here, okay? So I think that there are quite many small details over here, kind of consistent with, it's still consistent with what we said in the lecture. I'm just adding a little bit more details about when you have reference type in your expanded class, what should you expect to see, okay? All right. It's a very long response to your fellow students' question, but I thought just to be complete. Okay. In the last assert statement, so Amir, which one are you saying? You mean the example number 3 or number 2? Number 2. Okay. So when you say the last one, are you referring to this one here? Is that what you're referring to? Okay, good. That one there. It's not really using reference comparison. Okay, first of all, we are comparing EB1 with EB2 using equal, right? So that one there is going to be as if, because they are both expanded type, B1. So it will be as if you say EB1 tilde EB2, which is as if you say EB1 dot is equal EB2. But now the question is, which version of ESequal are you calling, right? Okay, you got it, good. It's going to call the default version, right? As I said before, default version. Okay, just be careful, right? You always have to see what's really the object you're comparing, whether you're comparing expanded type or reference type. EB1 s. Okay, I got some tricky question over here. Let's try. So let's see. Watson is suggesting the following. So EB1 dot s dot deep twin versus EB1 dot deep twin dot s. Okay, interesting. You know what? Let me explain this more properly, okay? EB1.S.deepTwin. And also EB1.deepTwin. S. Okay, that's what you're asking, right? So when you say are they the same, it depends on what you mean by the same. Do you mean by reference or do you mean by contents, right? So let's try both. Let's say EB1 is over here, right? Oh, sorry. B1 and then EB1. And then we have I, S, let's say 2, maybe Alan again, okay, let's say. And then, okay, let's try this. When we say the first one over here, EB1.S.deepTwin, you're basically saying that EB1.S is referring to Alan here, you're just making a new string. Okay, that's what you're doing, okay? On the other hand, when you say EB1.deepTwin.S, okay, first of all, you want to make a deep twin first, right? You're going to follow the order of evaluation. EB1.deepTwin is going to be, let me draw that here, right? So EB1.deepTwin, I'll just say DT here. And then B1, and then you got I, you got S, right? So deep twin, 2 will become 2. Alan will be just another Alan here. So now when you say .S, it's really referring to this Alan over here. So if you compare by references, of course, it's going to be false. If you compare by tilde, it's the same string. It's going to be true. So what's saying? Does it make sense? I hope. Very good. Okay. Let me just write it down, just in case you want to refer to the notes. If you say equal over here, it's going to be false. Okay. If you say tilde over here, it's going to be true. Okay, just as it notes. All right, guys, it's just about the example I want to present more, just about the expanded type. Do you guys have any more question about expanded type before I move on? The next one is about once routine. Okay, everybody's happy? Okay, now I get a question here. Let me read it out. If a class is not expanded and we have a string attribute reference type, do we have to explicitly initialize it? Yes. Okay, don't get confused. Void safety checks in IFO simply means if you got any reference type that is not initialized, then you will get a void safety error. Okay, let me just show you both. Okay, quickly. Okay, that's a good question there. Let me talk about this very quickly. So what I would do is like this. If I say creates make, and then let's say I got string s of type string, a reference type. Of course, it applies to any reference attributes. And then if I say make over here, okay, if I just say do and also end, nothing, okay, just do nothing, okay. If you do this one over here, it's going to tell you that it's going to be an error. So this one here will be compilation error. Because S over here is default to void. So the default value over here for S will just be void. So you should not leave it as void. So that's always disallowed. You definitely get an error. Okay. On the other hand, let's say if you got expanded class, okay. Expanded class, let's say full and bar, let's say. Okay, let me, I think that'll be enough for me over here. Okay, let me just move that a little bit. Okay, so now let me say, okay, for the expanded class, typically you will just use a default constructor. Remember, as I said before, implicitly for EB1 and EB2, you're calling the default creates, which I talk about over here, right? Default creates. Okay, so let me just do that quickly. So you would say creates, default creates. And then, of course, you will say default create over here. Okay, again, if you say do and end, and then you simply do nothing over here, right? And then we still have the string s of type string. Okay, you can see I try to make the class very similar, right? So now you can see this. This will also, you can see we simply do nothing, meaning that the string value over here will just be default to just void. Okay, so you will get the same compilation error, just the same compilation error. Okay, Nora, does that answer your question? I hope. Very good, very good. Okay. But don't worry, for the quiz, it's not this tricky. So as I said before, for your quiz, if you only worry about the quiz, don't panic too much. As I said, you want to focus more on the big picture. We talk about expanded type. Understanding what we said in the lecture about expanded type will be enough. So I think you can think about what we covered today. You still got time to digest that before the exam. However, for the quiz, you want to focus more on the singleton pattern. Okay, that's something I can tell you. Okay. Okay, so now let's talk about the once routine. Okay, that's the next question. So I simply just reuse the block of code that your fellow student provided on the Google Doc. I hope they wouldn't mind. Okay, I'm just being a little bit lazy to recreate them. What they're referring to is this particular code fragment from your lecture. Remember the example we used. We simply say new once array, and also we got a new array over here. The difference is this is once. This is just regular, ordinary routine do. Okay, let's see how we can do this. Okay, well, we already traced the code that's actually in your lecture. So let's trace your colleague's code. I can see where their confusion might come from. Let's see. They were asking this. In the lecture, well, I only use A over here. And then I simply say ARR1 is assigned to A.new once array. I say ARR2 is also equal to A.new once array. That's what you saw in the lecture. We don't have B, right? That's what we said before. And now your colleague was asking, what if we try to call the new once array on different context objects? Are we going to get a similar result? Okay, let's take a look. You can see what the question is, right? I think it's a valid question. Let me just move undo to the clean one. Okay, let's try to trace it quickly. So now you can see A and B. Apparently they are not expanded, so you must initialize them. That's pretty good. So let's try that first. So we got A and B. So that means A is now pointing to an object here of type A. And according to our definition over here, there is no attributes, right? So we just say A like that. And then we also got B is also referring to the A, right? You can think about, well, normally when we visualize your object, we only show the attributes. But you can think about they also contain the definition for new once array and also the new array, the definition, right? I can also put it there if you like, if you prefer. So the new once array and also the new array, their definitions are over here for you to call. New once array and also new array, the same definition, right? Okay, so that's about this part over here. Let's now try this. Number one, let's try with ARR1. Okay, ARR1 is assigned to, so it's going to point to somewhere, right? Okay, I'll do that later. And then A dot new once array Allen. So now you can see the context object is actually A, which means A dot new once array. We're referring to this particular definition. Well, it's just referring to this block basically, and that's the very first call to this once routine, which means we're going to bother to execute the body of the code over here, the 2 lines. What that will do is it's going to create an array, initially empty, and then we're going to force Allen over here. You can see Allen here. That's the first time, right? So Allen is going to be inserted to the end, index 1, and that one is pointing to Allen. Okay, and then ARR1 is going to point to it. Okay, so hopefully everybody's okay with the first one. I think the potential confusion might come from the second one. Okay, let's do the second one. The second one here, we'll say ARR2 is actually assigned to something, right? and then we say B, so it's a different context object. So we are saying B dot new ones array. So we are calling this version of here. However, since we are talking about the same type over here, so the NOA here is just referring to just the same ones routine over here, just the same. However, remember we said before, if you're calling the same once routine, if it's not the first call anymore, then you will actually have to return just the reference of whatever that's returned in the first call, right? So what I will do is new once array, and then you say mark. So now this time you're going to say mark. However, since it's already the second call, so you will be ignored because it's the second call. So what I will do is simply just going to return just the reference to this particular array. So what I will do is ARR2 will still point to the same over here. So my point is, when you are calling the once routine over here, it doesn't really matter what the context object is, because the context object is simply of the same type. And then whenever you call that, it's just going to distinguish between either the first call versus the subsequent call. Let me just draw some connection over here, okay? Remember how we use the singleton pattern, right? The way we do it is by using this. If you remember, we say local in the account, right? I'm just going to simplify that a little bit, assuming that you're familiar with the singleton pattern. We say that, let's say bank data access. If I say bank data access over here, bank data access, remember that one there is actually expanded type. Okay, and then I'll say do. Let me just do what we did in the lecture, and I'll expand it a little bit for you. And then we can say, let's say we got some data over here. Let's say data 1 and also data 2. Okay, that one there will just be bank data. Okay, so now let's do the first one. If I say data 1 is assigned to BDA dot data, right? So the data over here is the once routine. You can look up your definition for the singleton pattern. Okay, so now basically the previous question here was really asking, what if I also got another BDA2 of the same type? So now if I say data 2 is also assigned to BDA2, even though it's not necessary, but we can still do it, dot data. Again, we are really calling, because BDA and BDA2, they are both of the same type. So we are really calling the same routine over here, right? The same once routine. However, the crucial difference is now in the second call, right? Since it's already the second call, so we know that this guy over here, okay, think about this. When we are calling this for the first time, it's going to create this particular bank data, right? Bank data, and then whatever value it is, right? And then data 1 is actually going to point to this particular bank data. And then when we are calling this data here for the second time, right? Since it's the same once routine, so we are not creating any new object over here. Instead, we're just returning a reference for the data 2 to copy. In that case, data 2 will still be pointing to the same bank data objects. Okay, it's a quick analogy. Compare with this example here. They are consistent. Okay, guys, any questions about the once routine? That's the only once routine questions from the Google Doc. Any questions? Everybody's okay? Okay, good. All right. Okay, let me go a little bit further. Okay. I also saw, okay, so these 3 questions are actually related to each other. Okay, so I would definitely like to answer them all. So it's really about this particular example from your lecture slides, this one here, okay? So remember what I said in the class. Okay, let me just remind you very quickly. I think that maybe the best way to also encourage to really get convinced is by trying this out in EStudio. I did type some starter code to get for you, so you can save some typing, but I'll make it available to you so you can also try that out. Let me just recap very quickly what we said in the lecture. Supplier, right? And then we got this is one export status, and this is the second export status. Okay, so now remember once more from the lecture. Okay, when I use this client one, okay, so this is the export status. So this is export status for, oh, you know what? Let me write it out, otherwise you might wouldn't know what I really meant by EA. So this is the export status for using the make as a constructor. On the other hand, this one over here, the second one, right? The second one over here, client number 2 over here, right? Whatever you put inside is going to be basically the export status for using as a command. Okay, so the question goes like this, the first one. Okay, when you actually see the, I know what the question is, so I can answer directly, but you can also, I'll make the notes available so you can also read your colleague's question. Okay, the question was like this. So now it's like this. When you look at this particular line, okay, if you look at that over here, why would this not compile? First of all, it wouldn't compile because over here under, so think about what a compiler would do when you're trying to run this line. So they will see that since you're using the create keyword over here, so that means the make over here is being used as a constructor. So now the question is this allowed? Apparently it is not allowed, because in order to be used as a constructor, only client 1 is allowed to be the context, but the context now is client number 2. So this is not good. So this is not going to compile. Let me say that first, okay? And then let's consider also this line. Let me compare side by side. How about this line over here? Again, since you know creates, again, is a keyword over here. So now the make is going to be used as a constructor. This will be allowed, okay? Because you can see under the context of client 1 is definitely listed as one of the contexts over here for client number 1. So that's okay, right? This is okay. Your fellow student's confusion goes like this. However, when you actually go to the next one, when you say s.make over here, you can see now we don't have any create keyword. We don't, right? So that means this particular usage over here for s.make, let me just use a different color. Okay, it really corresponds to here. S.make over here is really, you're really trying to use it as a command. Okay, so now, and this one is not allowed because you can see to be used as a command, you must be under the context of client number 2, but now we're in client number 1. So that's why it wouldn't compile. So the question was, how is it possible that you can use it as a constructor, but not as a command? I would say these two ideas are completely independent. Not being able to use as a command doesn't really mean you cannot use it as a constructor, and vice versa. Okay, let me write it down here. Okay. So you want to think about using a command with a context objects. For example, when you say s.make, okay, that's number 1. And number 2, using a command to initialize, to create an object. How about that? To create for example, if you say create over here, s.make. Yeah, of course you want to pass some value. Let me just say 2 here. Doesn't matter. Okay, so 1 and 2 are completely independent. They don't affect each other. So that's the point I'm trying to make. They don't. So they are completely independent. Completely. Okay. Let me see this. Okay, something to do with the singleton pattern. I'll get to there, Amir. I'll get there in a moment. Okay. Okay, there's something I want to try to show you. Okay, when you see the starter code I made available to you tonight, you can actually see that. Let me just show it to you quickly. Okay, if I go to that's about the first example there. Let me just go there. There's another one I make for you. Okay, so let me just say compile. Okay, so now if you look into the model there, you can see client number 1 and client number 2. That's exactly the setup, right? Also, we got supplier. Okay, at the moment you can see that we simply got creates over here. And also, that's a so this is an export status for the constructor. I simply make this into comments. So it's as if we said public right now. And then over here, we say also, I commented out, but there's also any class can also use make, right? So that's why currently client number 1 and client number 2, they can definitely use the make as a constructor or to use it as a command, because currently there's no restriction over here. But now let's just do one by one, okay? As soon as, that's something you can play as well, you know, by using the source code. As soon as I say this, right? What am I trying to restricting over here, right? I'm trying to say now only client number 1 will be able to call the make as a constructor. That means client number 2 is no longer able to call make as a constructor, right? So now if I try to hit compile, where do I expect to see compilation error? Client number 2. If I do that, it's going to say, now in the context of client number 2, I'm trying to use the make as a constructor, right? So that's why the compilation occurred, right? Hopefully you see the first illustration here. Let me go back to supplier over here, okay? Let me just get rid of this guy here, okay? Just say put into comment again, okay? Everything still compiles. What if I try to do this one here, right? If I do this one here, so that means right now, only client number 2 can use the make as a command, whereas any class can actually use the make as a constructor, right? That's basically what the export status is saying. So now, if I try to hit compile, where do I expect to see the compilation error? It should be client number 1, right? Because currently we do have client number 1 who's trying to make use of the make as a command. If I say compile over here, so now if you click on that, you can see the error is about using the make as a command in the context of client number 1, right? That's exactly what the compiler is trying to tell you, all right? Okay, hopefully that makes sense for everybody. Okay, there's one more thing that your fellow student was asking. That was very good, okay? Jahao was asking, can we have a routine only in the creates, but not in the feature? Are you trying to say this? Okay, let me just make it compile first, okay? Jahao, I'm not exactly sure what you meant, but I'm guessing. Are you trying to say, I simply don't have this command over here, I simply put a make under the create? Is that what you meant? I want to double check. Okay, good. So guys, the question was like this. He was asking, Jahao was asking this, is it possible to only list the make over here under the creates without defining this? The answer is no. You cannot, with some do and body. Okay, you were basically suggesting this. That's what you're suggesting, right? No, that's syntactically incorrect. I'm glad you asked. If you try this, first of all, if it's a compile, you simply got syntax error, okay? Because, as I said in the line number 0, under the create clause, you're only supposed to put identifiers of the existing commands. You're not supposed to put any implementation, number 1, right? So this is a syntax error. You simply just cannot do this. Okay, and number 2, will this compile? Well, as I said before, you have to list some existing commands that can be used as a constructor. So now if I say compile, it's going to say no, because invalid creation procedure make, because you are referring to make, but make does not exist in this class. That's why it should be a compilation error. Jahao, does it make sense? Good, very good. Okay, that's good. Yeah, I think this kind of syntax problem, please just ask. I can always explain. Okay. Okay, that's good. So guys, I think yes, question.
I have a question.
Go ahead, please.
Sorry. So if create has client one as an export status,
You mean this here? Okay.
Yes, if it is like
yeah.
there, then client two can never use make as command because they cannot ever instantiate.
I see what you mean. I see what you mean. Yes, yeah, that's true. Even though this part over here is public, right? Even though that's public. Yes, I see what you mean.
Okay.
Let me
so
try to.
They cannot.
They cannot. They cannot.
Okay.
The reason that they cannot is because you can never create an object to begin with anyway. So even though the export status tells you you can, but you're not going to pass the void safety check, basically. Right? Okay. Very good. Okay. So guys, I think that there are two more things I want to mention over here. Okay, two more things, please. I want to mention quickly. Let's say we still go back to the same example as you learned from the lecture. Okay. Now, if I say compile, okay. So now, let me just go to client number one and client. Okay, let me just say this. Okay, let me just go back to the iPad over here. Okay, so let's say this. Your colleagues was wondering about, given that these two usages of the make as a constructor is simply invalid because only client one can do it, right? So now they're wondering why I would say this is actually okay. I would say when I say this is okay, simply because the compiler wouldn't complain about it, okay? That's what I meant. I will show you why, okay? When I say okay over here, that simply means compiler would not complain about this usage. However, your fellow student was thinking this way, which I think is pretty good. They were thinking this way. Because we know that these two creates are simply just not possible, meaning that when you get to this point, S might just be void conceptually. Meaning that if you try to say S.make, even though it's allowed according to this, but it would just be void safety error. That's what your fellow student was wondering about. I would say that's not incorrect thinking. However, let me tell you just a little bit more about how the IFO compiler works, and then you will see why. Okay. So let me just, okay, I will say question mark over here. Okay, let me just tell you, I wrote something down for you, actually. Let me write it, put it here. Okay, so this is basically your college question. You can read it through if you are curious about how they phrase it. But I would say this. The answer is, whenever the compiler is trying to compile your code, right, they kind of do at least two stages. Stage number one, they will check to see all the qualified call. When I say qualified call, I simply mean the use of the dot notation. Whenever they say, for example, S.make over here, this is more like a qualified call because it qualified to the context object S, right? And then the way they do it is it's very simple, okay? So they will simply say, if I try to make the S.make in the context of some class, for example, a class maybe A. So now all they will check is whether the class A is listed as the export status for make used as a command. That's what they will do, okay? In this example over here, when we are trying to, when the compiler look at this, they will simply look at to see S.make is made using, is made in the context of client number two, and client number two is indeed in the export status. That's why, as far as the compiler is concerned, for this particular stage, stage number one, this is okay. Only when you can get to stage number two, which is about void safety, will you actually tell, will you actually say the target here might be void. However, in this case, we do not even get to stage number one. We do not even get to stage number two because you can see over here, when we have create S.make over here, this is some error that will really cause stage number one. Check. Okay, let me just write it a little bit better. So that will be stage number one. Stage number one, check to fail. So that means if you already fail on this particular stage number 1, you don't even get to stage number 2. That's why you don't see that compilation error. Okay, it's a very subtle detail about the compiler, right? Let me just show you how you can see that from the compiler quickly. Okay, if you go back to EStudio over here, so now you can see these are only the stage 1 checks, right? So if you go back to that, it's exactly the errors I showed to you before. So you can see number 1, you can see you cannot use s.make under the context of client number 1 as the command, right? That's compilation number 1. Okay, that's a qualified call where the make is not used in the right context as a command. Okay, the other two, for example, you cannot use create s.make over here, right? So that's simply not allowed. And also in the context of client number 2. And also you cannot use also over here create s.make, the second one. You can see the compiler does not complain anything about s.make at this point because we're still in stage number 1. So as far as stage number 1 is concerned, you're just using the call of make as a command. That will be allowed. Okay? Okay, hopefully that makes sense. All right? Final point, I want to talk about the export status. Okay? One of your fellow students, I think they heard from my previous Q&A. When I say client number 1 is allowed over here, I meant client number 1 and also any subclasses that inherits from client number 1. Okay, I will give one example to you, and then I will draw some connection to your lab number 2. I'm not sure if you noticed that subtle detail. Okay, let me say this. Let me just create under model over here a new class. Clients number 1 child. Okay. And then what I will do is I'll simply just do inherits. And of course, starting from this week, we also review inheritance. You will see that in the lecture. Let's say client 1. Okay, I think you may have to use to say creates. Also, you need a constructor for that. Let's say create make. Oh, you know what? Let me do this. I want to do the simplest possible example, not to confuse you too much. Let me still say public over here, and also public over here, all right? And say compile. Okay, now everything compiled. Let me do the following, okay? So now let me just do this one here. If I say client number 1, so I'm saying, okay, you know what? Before I do that, can I just do the following? Client number 1, can I just copy everything over here, right? So I'm still trying to use them. Client 1 child. And then, okay, I believe everything is good. Let's just compile. I don't want to make things compile, so let me not worry about the make over here. For the test, okay, let me just say maybe test 2 over here, okay. And then you said client number 1 is, test over here. And when I go to client number 1 child, that one there, I should really call it test 2, possibly. Okay, everything compiled. So don't get lost. I basically just created the client 1 child, basically. And then I simply copy exactly the same usage of the command make, okay? And also use it as a constructor. So now everything compiled. What I want to illustrate to you is as follows. If I go back to supplier over here, so now as soon as I comment this out, meaning that I'm saying that only client number 1 is able to call the make as a constructor. So now my question is, if I get this done, get this export status present, am I going to get any compilation error in client 1 child that tells me I cannot use the make as a constructor? The answer is no. Okay, that's the point. If I say compile over here, so now you can see all the compilation error message is about client number 2, meaning that as far as the client 1 child is concerned over here, you can see using the s.make, is absolutely fine, right? Because, okay, let me just put a point over here. This is okay because the export status of make as a constructor includes client 1 and its descendants. How much is just a child classes? Okay, guys, I hope you see the point. Okay, so now everything will still work. So the only error messages we got is from client number 2, which means client 1 child is okay. Okay, let me just draw one more connection to your lab number 2. Okay, I'm not sure if any one of you pick up that point over there. It's actually related. So remember for your lab number 2, okay, let me try to recall the details myself quickly, right? For your lab number 2, let's say you go to your linear DB class, okay, linear DB. So you go to class, and then you say linear DB. Okay, and then there's a feature over here. And then I'm not sure if you remember. Okay, let me have a little quiz on you guys if you remember. Okay, we got keys over here, you know, whatever type it is, and also we got values over here. Okay, and then you got the rest of the class. Okay, that will be whatever I want to show over here. Guys, do you remember what we put over here? Anybody remember? Anybody? If nobody, that's okay. I just wonder if there's anyone who actually pay attention to what we put over here. Do you remember? We actually put 2 classes over here. ES test, I agree. What's the other one?
Iteration cursor.
Wow, impressive. Exactly. Iteration cursor. Okay, that's good. Okay, so now let me tell you why this is also relevant to the subject we are talking about. Okay, so let's say, remember for linear DB, we actually got some client supplier, right? So we actually say over here, client supplier. Okay, so we got a new cursor over here. Okay, and then you can also see the solution diagram is also something there. Okay, so now when you get to the class, it's a linear IT, right? And then we got something here, and then remember, and then you can actually pass. You can actually pass the entire linear DB, right? So you can see the make over here is actually maybe the DB, also linear DB, right? Something like that. Okay, and then somewhere in your code, you can also say you can actually refer to DB over here, linear DB dot keys. Also linear DB dot values. So now here's my question to you over here. Hopefully the answer is obvious to you. Okay, so now DB over here is of type linear DB. According to linear DB, the keys and values are only exported to iteration cursor, but not really to linear IT. So why would it compile? I hope my question is clear to you. And let me repeat again, okay? In the linear IT class, in the context of this class over here, so given that the make over here is linear DB, so we can refer to db.keys, db.values. However, these 2 attributes are under the export status over here to say only iteration cursor. But how is linear IT be allowed over here? That's my question. Would this compile or would it not compile? Yeah, Nina, you said inherits from iteration cursor. That's exactly the point, right? So that's the missing piece over here. So now you can see this one here inherits from iteration cursor. So now that's what I said. So iteration cursor, not just that, but also it can be used. Also can be used by iteration cursor's descendants. Right? This is why when in the context of tree IT, you can also refer to, the even in the tree IT, you can also refer to the keys and value, but you just didn't do it that way. All right. Okay, guys, I think that makes sense to you. Okay. I think for the export status, we also talk about quite many small details today. Okay. Hopefully that makes sense to you. Okay. Let me see how many more I got left. I still got 1 and 2. Oh, I only got 2. Okay. So how about let me just finish at least one of them. Okay, I want to finish in time. Okay. So we are so this is your colleague's question over here. Okay, let's take a look. Okay, I think this one is somehow similar. Let me read it to you. Okay, let's read it together. When we are creating a once routine in a class after the first call, okay, and then that result is cached to what they said originally is cached to all instances of this class. I would say what your colleague said was not accurate. I think what they meant to say is actually cached to all the callers of this particular data routine. That's once. Okay. So now if you take a look at that over here, you can see the data access over here has this particular once routine. That's data, right? So what I'm trying to say is, the data over here, because that's once, you have to distinguish between the first call and also all the subsequent call. Okay, either that or that, either 1 or 2, right? And then when your colleague was saying all instances of this class, so not really all the instances of data access, not really. So basically, if you're trying to use the data access in the context of any class, in any caller context. In that case, the first call is going to execute this particular line of implementation, and all the subsequent call is actually going to just return the same reference. So let me use the, so basically that's your colleague's example over here. Let me just explain that right away, okay? Let's say you got client number 1 over here. You also got client number 2 over here, right? I think in your lecture example, I'll just use one single account, but it's really the same, okay? Think about in this way, right? So now let's say this. If I have a client code over here, let's say we got, think about we're trying to do this in the sequential order. Let's say when you first call, D is assigned to access data, right? So this is really assignment over here. And also, if this is the first call, let's say, if this is the very first call, that means when you call .data, it's going to execute this particular constructor, right? So what that would do is it's going to create this particular data objects, and then with whatever that's here. And then the D is now going to point to just this data object. That's the first call. Let's say later on, we try to do from client to context. And then we try to say D is assigned to, let me use maybe pink. And then we try to say D is assigned to access.data. So now we're calling the same once routine, but it's the second call already. So that means we're not going to execute this anymore. What we will do is the D over here is not going to point to just the same objects. So basically, I will draw maybe some connection maybe tomorrow if we have time to the ETF projects. Again, you definitely need to understand the singleton pattern in order to do your ETF project, especially how you can get access to the model. That's something I'll try to explain a little bit more tomorrow. Okay, we got about 2 minutes. Okay,
I have a question.
Go ahead.
Yeah, for this one. So, the once routine, it's pretty much bounded to the class, not the object. Is that what you're saying?
It's pretty much bounded to it's bounded to the class because in order to call that particular data, right, you need to have some context object like an access. However, you shouldn't really think about it's really bounded to this particular class. It's really bounded to the global counter to see whether it's the first call to the data or it's the second call to the data. If that makes sense to you.
But so when because in the first client and second client, the data access to different objects, right?
Correct.
But they still share the once routine.
Yeah, exactly. So of it, I think I remember the thing as it's similar to this. Let me just go there. remember this example here? Think about it's exactly the same. So now we got two different A objects, right? We got A and B, right? A and B over here. Think about this is one data access. This is another data access objects. However, you're really calling the same once routine, that is data. So that's why only the first call to the once routine is going to create a shared data objects. But starting from the second call onwards, you're just going to return a reference to the same data objects.
And it doesn't matter if this was called from two different objects.
Doesn't matter. Yes, correct. Doesn't matter. Think about this only. Think about it doesn't matter how you actually call this once routine. Well, put it this way. Let me just go back here. Okay. Let me explain this properly, and then we should call it a day. Okay. I'll do this within 5 minutes. Okay. So guys, let's use the example over here. Okay. So we got our singleton pattern over here. Let's say. Okay. So now let's say inside the context of this client class. Okay. Let me just do it quickly here. So we got data access over here. There's one object here. Let's say we got another one. Let's say DA number 2. That's also bank access. Okay, and then when we try to say, let's say data and also data 2. Okay, just make some additional. And then here I say data 2 is also assigned to, I'll say DA2 dot data. Okay, so now what you should notice is data over here and DA2, they are different objects, right? So now what's happening at the runtime very quickly. When I say data over, when I say, data access, I kind of highlight too less, data access over here. What's happening at the runtime is like this. For data access, it's expanded, right? So I would say bank data access, right? It's of this type. And that one there is really the data access. And that one there really contains the definition for the data, right? The definition. I'll say data definition. And then also for the second one, we got data 2. So we got data 2, which will just be another object of the same type. So bank data access. And then they basically got the same definition, right? Just for the same. Okay, I'll put it here. Also the data definition, simply identical. So now let's try to execute at the runtime, right? So when I try to say the first one, not this one here. When I do the first one over here, when I say data is assigned to over here, data access, I'm talking about data access over here, dot data. So I'm calling this once routine for the very first time. For the very first time, I'm going to execute this particular line over here. What that will do is it's going to create a bank data. So it's going to be bank data, right? So bank data and whatever value it is. And then data is going to be assigned to, so data is assigned to this particular bank data, right? Okay, let's do the last step. So now you're going to say DA2.data. It is true, data 2 is a different expanded object. However, it's really containing the same definition for the same once routine. So now when you execute this same block of code, because it's no longer the first call, so we're going to bypass this particular line. Rather, it's going to return just the reference for this particular object in order to assign to data 2. So what that will happen is data 2 over here. You know what? This one thing I labeled wrong. I meant DA2. Sorry about that. So that's DA2. Okay, that's the only thing I did wrong. Okay, DA2. And then now for data 2 over here, so data 2 is now going to just refer to just the same objects. So it's still singleton pattern. Even though you're using different context object over here, different context object over here to use data, but since you're calling the same once routine, so it's still the same.
Okay, I got it. Thank you.
Very good. Okay, guys, any last minute question you want to ask me before I let you go? Okay, seems to be good. So basically tomorrow we'll get one more thing, maybe briefly about here. There might be additional questions on the Google Doc, which I will talk about tomorrow. Otherwise, I think this week it's rather straightforward. I think I resolved all the clarification, hopefully, confusion for you. All right, thank you for staying with me, and I'll see you tomorrow if you can make it. Otherwise, I'll talk to you later. Take care. Bye-bye.
Thank you.
Bye-bye.
Thank you.
Take care.